Okay, so in this video, we are going to look at graphing our trig functions. At this point, we've worked with our trig functions on right triangles, using our trig relationships, SOHCAHTOA, TOA, all that. We have looked at the unit circle. I graded all your unit circles. For the most part, you guys did well, other than maybe missing positive and negative signs. So make sure to look at that to make sure you're keeping all your signs correct. Now we want to look at these trig functions from a different perspective. We want to graph them. So the way we're going to graph them is the way you would graph anything that you hadn't graphed before. We're going to plot some points and see what's going on. And as far as it goes, I've already got these labeled. For most trig graphs, there's about 5 basic points that are important. Thinking about the unit circle. 0, pi over 2, pi, 3 pi over 2, and then 2 pi again, which would get me back to 0 because we understand things repeat. So we're just going to plug those into our function. I'm going to rely on your knowledge of the unit circle. If you don't have it memorized yet, pull it out so you can use it and help us graph this. So let's see. We know in the unit circle, sine is the y value. So let's see. When x is 0, what is sine? When x is 0, we're at the starting point 1, 0 on the unit circle on the right. And sine is the y value, so sine is 0. When x is pi over 2, that's 90 degrees, that's the top of the circle. That's the point 0, 1. Sine is the y value, so it's 1. At pi, that's 180 degrees, that's on the right. That's the point negative 1, 0. Sine is the y value, so it's 0 again. 3 pi over 2, that's the bottom of the circle. That's the point 0, negative 1. Sine is the y value, so it's negative 1. And then at 2 pi, we're back to where we started on the right part of the circle, which means we get sine equal to 0 again, and it will repeat. So now, given that, we should be able to plot these points and see what's going on. So let's see, at 0 I get 0. At pi over 2 I get 1. At pi I get 0 again. At 3 pi over 2 I get negative 1. And at 2 pi I get 0. Now just connect the dots. The one thing I would say, these sine graphs, they're continuous functions, they're differentiable. That's a calculus term, don't worry about it. But it means they're smooth, like polynomials. So don't make them pointy, make them nice and curvy, like a wave. And there we go, there's our sine wave. But we know if I kept on going, if I did 5 pi over 2, 6 pi over 2, so on and so on and so on, all of these sine values would repeat. Think about the unit circle, which means this wave right here is going to repeat. It's going to go up again, then back down, then back up. And by the same token, on this side, it'll do the same thing backwards. It'll go down, then up, then down, and it will keep repeating. And we get a sine wave right there. As far as it goes, there are certain key points of this graph that we're going to be using and we need to know. So first off, we have what's called the amplitude of the wave. The amplitude is essentially the change from the equilibrium point, the middle of the wave, to the top of the bottom. The other way of thinking about that, if you want to find the amplitude, find the maximum value of your wave, that's y equal to 1 right there. Find the minimum value, that's y equal to negative 1. The total displacement between them, total distance, is 2, negative 1 to 1. To find your amplitude, cut that in half. 2 divided by 2 is 1. So the amplitude here is equal to 1. Then we have our period. We discussed this when we were looking at properties of functions earlier. As far as my period goes, well, we said the period is how often the wave repeats, or in terms of the unit circle, how often the unit circle repeats, but it works the same. The wave starts right here, goes up, down, goes back to 0, and then it starts repeating. So this is my period right here, 0 to 2 pi, which is exactly what we said when we did the unit circle. The only other thing I would mention, which I mentioned in a video previously, as far as the properties of this goes, we said that sine was an odd function, which on a unit circle can be a little bit hard to see. But when you see the graph this way, it makes it easier. Let's see, an odd function means f of negative x equals negative f of x, or if you will, it's symmetric about the origin. And here you can actually see that clearly. If I take this part of the wave, I take it to be symmetric about the origin, I flip it, then flip it again, and I end up over there. So the symmetry here is actually easier to see, and we can see that it's an odd function. We are going to come back to this and mess around with it a lot more, but I want to go over one or two other graphs first. Okay. If that's sine, the next one we want to look at is cosine. So we'll do the same thing. X values, f of x values, and we'll do the same 5 key points, 0, pi over 2, pi, 3 pi over 2, and 2 pi. One thing I will point out as I set this up, we have 6 basic trig functions. I am not going to graph all 6 of them. I actually left it as part of your homework for you guys to graph a few of them on your own. I simply don't want to take all the time to graph all 6 individually. Once you graph a couple of them, it should be pretty clear what's going on. And using 5 basic points, you should be able to graph them. So here, cosine, let's see. In terms of the unit circle, cosines are the x values. So really quickly, when x is 0, we're at the point 1, 0 on the right of the circle. The x value is 1. Pi over 2, we're at the top of the circle. That's the point 0, 1. The x value is 0. At pi, we're on the left, 180 degrees. That's the point negative 1, 0. The x value is negative 1. 3 pi over 2, that's the bottom of the circle. That's the point 0, negative 1. X is equal to 0. 2 pi, we're back on the right at the point 1, 0. X is 1 again. And we see the repetition from 0 to 2 pi. So now plot it. Let's see. At 0, I get 1. At pi over 2, I get 0. At pi, I get negative 1. At 3 pi over 2, I get 0. And at 2 pi, I get 1, back where I started. Maybe I'll extend this a little bit more on both sides. And now again, just like with the sine, connect the dots. Make it nice and smooth. It goes down, and it goes up. And there we go. There's my cosine wave. We understand that this thing is periodic, just like the sine wave, just like in the unit circle, which means this wave will keep repeating. So it will go down again, and then up, down again, and I ran out of room. And then it'll do the same thing on the other side. It'll go down, and then up, down, and then up. One thing to keep in mind, we have seen that there's a clear relationship between sine and cosine. We mentioned there were cofunctions of each other. If you look at the waves right here, the cosine wave starts right here and ends right here at 2 pi. But if you kind of shift your perspective a little, if I start, I don't want to mess up my graph too much so it gets confusing, but if I start right here and then right here, I go up, down, up, that's actually a sine wave. They're the exact same wave, it's just a cosine wave shifted over gives you a sine wave, or a sine wave shifted over gives you a cosine wave, based on your perspective. We're actually going to see a little bit of that in the next video when we talk about transformations of these graphs, but essentially they look the same. You just have to remember which one starts at 0, 0, the sine wave, and which one starts at 0, 1, the cosine wave. Sine wave starts in the middle of its equilibrium. Cosine wave starts at the top at its maximum. But once we have this, again, we care about the properties. So let's see, we need an amplitude, we need a period, And we want to know if it's even or odd, which we have already covered, but we can see it better here. In terms of amplitude, well, same as sine wave. The maximum here is at 1. The minimum is at -1. So the total displacement is 2. Cut that in half, you get 1. So my amplitude is equal to 1. Period. That's how often it repeats. But again, starts at 0, goes to 2 pi, then repeats itself. So the period is 2 pi. Yes, I know we did this with our unit circle. We can just see it again clearer here with the graph. In terms of even and odd, when we did this before, we said cosine was an even function. The other way of saying it's even is that it's symmetric with the y-axis. But again, if I look here, it's pretty easy to see. If I start right here, I do that. If I take that and flip it, I get that right there. So the symmetry is easy to see, and it's an even function. Well, let's see. This video is already 11 minutes long, so I think I'm going to stop right here because YouTube only lets me do 15-minute videos. And I'll make one more video where we graph tangent and then maybe one of the reciprocal functions, and I'll leave the other ones up to you.